mass. Okay? Huh? Frequency distribution, okay, when we have a quantitative data. Okay, yeah, we can summarize by using frequency distribution and okay, relative frequency distribution and percent frequency distribution. Okay, and then we can display this kind of information from data, this kind of information in what? By using yeah, okay, tabulating. What's the meaning of the tabulating? Tabulation, tabulating, tabulate, how we can display this kind of information? Tabulating, table. No, by using table. Okay. Yeah, we can display and we can summarize this kind of information by using table. Right? Okay, we call that as a tabulation. Absolutely, the quantitative data, we can display the quantitative data into a table, okay? That's easy. Okay, and iteration, okay. Okay, so we can, once we can transform our data into this information in table, okay, then what can we do next? We can display this table in graphical form. What kinds of graph can we use when we have a quantitative data? First, absolutely, we can display that. Yeah, what kinds of graphs? What kinds of chart? Okay, bar chart, possible. Bar chart. Okay, good. And pie chart, absolutely. Yeah, that's possible. Anything else? Dot plot. Okay. Yeah, we have more option. Good. And okay, and then this is matched with the pie bar chart, histogram. Okay, good. Okay, cumulative. Cumulative. Yeah, distribution. Okay, and that can be displayed in the table. Okay, the cumulative distribution can be displayed in the table, and then when we have the cumulative distribution, how we can display this? How we can display that, this cumulative distribution? By using what? By using what? By using what? No? Okay. I'll return back to here. So, this is the display of the cumulative frequency distribution. And then we call this is line graph. Line graph, okay? So, when we have a cumulative distribution, we can display that information in the form of line graph. Okay, and we will learn more about that. Okay, line graph. Okay, and anything else? Yeah, okay, yes, stem and leaf. Stem, leaf, display. Okay. Good. And however, So we can use tons of thousand different graphs to display the data, especially when we have a quantitative data. Okay? We have tons of thousand options. So we must be feel free. Good. And okay. Bar chart part. Okay, good. Roy. Good. And what is the difference between the bar chart and the histogram? Bar chart is commonly used to display the categorical data. Okay? Good. And however, yeah, we can use the bar chart to display the quantitative data. However, the histogram, yeah, the histogram only can be display the quantitative data. And what is the difference between these two? Graph. Bar chart, histogram. What is the difference? Okay, bar chart looks like this. While the histogram, yep. Okay, so then, what is bar chart, what is histogram? What is bar chart? Left, okay. What is histogram? Absolutely. We have only two options, 50%, 50% probability. So then what is the big difference between the bar chart and the histogram? What? Space, yeah, gap. There is a space or the gap. Okay? In the bar chart, there is a gap, or there is a space. That's true. And in the histogram, there is no gap. Okay? Good. And that is, why? Why histogram do not have a gap? Okay, yeah, absolutely. Because only we have the continuous quantitative data, yeah, we can display the data by using the histogram. There is no gap. Because that's continuous. There is no break. There is no break, and there is no distinctive something. And while the bar chart is clearly distinctive from each other. For example, the categorical data, okay, and this is male, and this is female. And yeah, okay, and third something, okay, whatever, okay. So yeah, can we compare the male and female? The female is larger than the male? No. Okay, this is not continuous. The data is not continuous. Okay, in this case, yeah, we must separate it from each other. Okay, we must separate it from each other. Okay, and however, this is 0 to 100. And absolutely, this is larger than this. So we can compare, we can do math, and that is continuous. The data is continuous. That's a bar chart and a histogram. Good. Anything else? There is, okay, Holly. Good. And yeah, yesterday we learned more. We learned more about when we have two variables. When we have two variables, okay, and we can display that two variables by combining those two variables, we make a certain table. Okay, variable 1 and variable 2. Then, how we can call this? Cross tabulation, and making that this kind of table is, we call that a cross tabulation, and we call this is cross table. Okay, good. When we have two variables. Okay, good. Carrie. So when we have two variables, yeah, maybe we can display the variable A, variable B. Okay? And then we make something like this. And how we call this? Scatter diagram or the scatter plot. Okay, we call this is scatter diagram or scatter plot. Okay, good. And we wanna. So then, yeah, when we draw the scatter plot, when we can draw the scatter plot, what kinds of information or knowledge can we draw? Okay. Yes. What is the relationship between these two variables? Okay. Relationship. Okay. Good. Relationship. And yeah, what if we have this kind of relationship? Okay. So how we can call this? Daisy. Yeah. What is the relationship between A and B? Positive. Positive relationship. And when the line looks like this, that's negative relationship. Okay. And then if there is no relationship that looks like a circle or something. Good. And that's okay. And CC. Yeah, return back to the histogram something. Okay, so if a histogram looks like this, and what kinds of information can we draw from this histogram distribution? Okay, first I want to say, okay, a certain data looks like this. When we have this kind of the histogram shape and how we can characterize this data. The left side, right side is almost same. It's same. See, left, right, same. See, see. When the left and right side is same, we call that this data distribution must be yeah, symmetry. Okay, symmetry. We call this is symmetry. Okay, symmetry. And yeah, I will say, I will give a very important insight from the scientists and engineers. And why do you think that the world is beautiful? And yeah, first of all, CC, do you believe that the world is beautiful? The nature is beautiful? Why? Why we feel very beautiful when when there is a word? Why? It sounds somewhat out of scope of the class, but however, maybe we can think about it. Why we feel beautiful? Something. If you think that the world is beautiful, why? Why world is beautiful? Because there are a lot of beautiful ladies, beautiful boys. This is not a philosophical question, but however, we'd better to think about it. Why? Why the world is beautiful? Yeah, okay. So, but let's make it more specific, okay? When you see a handsome boy, okay, and you feel very beautiful, okay, why? Huh? Okay. And I'd better to ask, okay, where is Bruce? Okay, Bruce. So when you see a beautiful girl, okay, so why do you feel the beautiful? Why that is beautiful? Why that beautiful lady looks beautiful? Huh? Because you can see her? Yeah, absolutely. But however, everybody can see her. But why do you feel very beautiful? This sounds very crazy question. This sounds very crazy question, but however, this is one of the most important philosophical and scientific question. Why world is beautiful, and why we feel beautiful. Okay, that is quite related with this question. Okay, Tariq, do you have any idea? When you see a beautiful lady, okay, why do you feel good? Why do you feel beautiful?
I feel good.
Yeah. Why, when you see a beautiful girl, do you feel bad? Or do you feel good? Feel good, okay. And why do you feel good? And why do you feel that is beautiful? That girl is very beautiful.
It's the law of attraction.
Okay, so attraction, why? Pardon? Huh? Yeah, why do you feel better? Okay. Yeah, comparing to another ladies, okay, a certain lady or certain girl is more beautiful. Why? Why human feels like that? Why humans feel something good or something beautiful? Brain, why? Why our brain feel like that? Why our brain react like that? Huh? Probably, but however, so we asked this question so many years. Okay? And we do better to have some clue or the answer, something. Why world is beautiful? Okay. Okay, Ali. When you see a beautiful girl, do you feel good or do you feel bad? Always, I'm very excited. I feel good. And why? Why we feel good?
I've seen so many ugly girls.
So many ugly girls? Compare. Okay, why do you feel that when you see somebody and she is ugly, she is beautiful? What make a difference?
Different parents.
Different parents? Uh-oh. But how about we have a technology, we have a cosmetic, plastic surgery. So we can fix the problem, absolutely. And if you're interested in that, okay, I will connect you with a few number of the good Korean plastic surgeons. Really? Okay. This sounds very crazy question. And why humans can feel good or why humans can feel beauty. Okay, but however, we cultivate not that knowledge throughout research and study. And simply because of this. Really. Okay? When there is a human face, okay, and there is, looks like this, okay, no, okay. Okay, when we see very symmetric, when we see a very symmetric shape something, okay, and we feel comfortable because that is quite stable. That is quite stable and that looks balanced. Okay, and this is just art something. But however, in the science, there is atom. Okay, and there is plus, there is minus. And when that is symmetric, the material being can exist. And then that material being looks beautiful. Okay. The balance. When we see a very balanced something, okay, we feel good. We feel that is beautiful. And balance means symmetric. Okay, so simply, symmetry is beautiful. Symmetry is beautiful. Okay, and so we love symmetricity. We love symmetry. And throughout the whole semester, you will see what's going on when we have a symmetric data distribution. And then when we do not have the symmetric data distribution, we have some troubles. We have some troubles. So, okay, then, yeah, return back to the histogram. So, yeah, ideally, the symmetric data distribution must be beautiful. But however, when we have this, it's not beautiful. Okay, and see, so how we can call this data distribution is we call this is skewed. Okay, skewed data distribution, skewed. And one of the benefit of using the histogram is the histogram can display the skewness of the data. Skewness. Is it symmetric or not? Okay, and this data shows the symmetric. And okay, so then is it? Yeah, what kinds of symmetry, the skewness this data have? Moderately, negative. Left, left. Left. Okay, so let's see. Yesterday we learned about this. Okay. So I want to make that shape. And then should you use the left hand or the right hand? Right hand push. Okay, so that we call this is right skewed. And this is positive skewed. Okay, good. This is positive. This is right skewed and positive skewed. Okay, yeah, so yeah, I had a lot of difficulties. What the hell is the skewness? And this is supposed to be the negative or positive or right or the left. And so I just use this. Okay, right hand. Yeah, use it as your right hand and push. Use the left hand, push. And left skewed is negative. Right skewed is positive. Okay, this is right skewed. This is right skewed. Okay, where is Kevin? Kevin, okay. So what kinds of example we have if that display that the highly right skewed or positive skewed? Yesterday we learned. That is related with the Pareto chart, Pareto rule. Highly right skewed data. What is the most typical, the right skewed data set? Cell. Yeah. Yeah. So what kinds of example we have that has a very highly skewed distribution? Right skewed, positive skewed. For example, okay, good. And Chloe, yep. Can you let me have an example that the data must have a very highly right skewed or the positive skewed? Okay, salary or annual income or national ownership of the national income, national wealth. Okay, so just that's the top 20% of people owns the 80% of the national wealth. That's a Pareto rule. Okay. Good. So this is not symmetric. This is not symmetric. Okay. And yeah, we will learn about what is the problem when we have a highly skewed data. That means when we have a not symmetric data distribution that has a few number of problems. And we usually cannot apply statistical analysis, statistical calculation when we have this highly skewed data set. There is a reason. And that is the reason why that symmetry is not beautiful. The symmetry is beautiful. Okay, good. And how about this? And this is my intention. Chloe, Bruce, Cherry, Jing. And what is a typical example of that has a very highly left skewed or the negatively skewed? Example here. And what? Yeah, exam scores and the GPA, the grade. Your statistics grade. And then I want to make it more push, okay, to the right direction, to A side. A minus, B plus, B minus, and C. Okay? I want to make it more highly skewed. Okay? I want to make it more push. Okay? So that is an example of the highly left skewed or negatively skewed data distribution. Okay? And then the histogram will be a nice start. Histogram will be a nice start to capture how the data is distributed. Shape. Okay, good. And just one more. Okay, Corina. Yesterday we learned about cross tabulation. And then when we have a cross table, we display the variable A in here, a variable B in here. Okay, good. That's good. So that's a nice summary. That's a nice summary of the quantitative data. And however, sometimes we encounter a very strange result when we aggregate these two variables together. Okay? And then when we do not aggregate the data, and then we can make a conclusion of something. And the smoking is bad. However, when we aggregate two data, okay, and then the conclusion will be awkward or strange or contradictory. And then in that case, how we can call that kinds of contradiction or this match or strange or awkward result? Yeah, in order to fix the problem. And then how we can call that problem? Blah, blah, blah's paradox. Whose paradox? Paradox. Whose paradox? Who found out that? Paradox. The word is full of the paradox. Paradox. What paradox? Yeah, Simpson. Yeah, Simpsons Paradox. Do you know the Homer Simpson? Homer Simpson. Yeah, you must see that. Huh? Who? Yeah, the Homer Simpson. Huh? Yeah. The Homer Simpson is bored. Yeah, okay. Yeah, give me a second. And I cannot draw. The Homer Simpson, yeah. Sure. Whatever, okay. So, Simpson is quite cynical. Simpson is quite cynical, and he enjoys a lot of paradox. Okay. Whatever. Yeah, that would be fun to see the what's the how the Homer Simpson is talking, and he usually use a lot of paradox. And whatever. Yeah, Simpson, a statistician, very good statistician, not invented, but however, he found out, we encounter this kind of paradox, and that is contradictory our general belief. And then he conceptualized this is a Simpsons Paradox. Okay, when we aggregate the data and when we display that together, okay, by using the cross tabulation, this kind of things, and then we can encounter a contradictory conclusion when we didn't aggregate that. Okay, we call that a paradox. The conclusion can be different. Okay, good. And yesterday we talked about the smoker case. And the smoker case shows that one of the Simpsons paradox, okay? Yeah, from the original data, the smoking is bad. But however, when we aggregate that, something was happened, and then the smoking is good for health. Okay, that's the Simpsons paradox. Okay, good. And lean. Okay, so when we have this kind of the awkward result, Simpsons paradox, okay, what should we do? How we can understand that Simpsons paradox? How we can address this paradox? What causes this kind of the Simpsons paradox? All data. Okay? Yeah, so simply, please check it again, your data source. Okay? Where you get the data. And the data is collected everything, or the data is collected correctly. Okay? Check it out. The quality of data is a big matter, and that causes this kind of awkward, the paradox. So please check it out. Check it again, and check it again, check it again. The quality of the data is most important thing before doing more sophisticated data analysis. Okay, anything else? Cumulative stem leaf, this. Histogram, okay, the symmetric is beautiful. Symmetry is beautiful. Yeah, please see that. Okay, so yeah, please see the beautiful lady. Okay, symmetry. Yeah, balanced. Okay, and there is left skewed data and the right skewed data. Okay, and the highly light skewed data. Okay, and yesterday we talked about the salary gap between the general employees, okay, average employee's salary, and the average executive salary. Normally, that is around 30 times. But however, there is an exception in the world. That is the US, and that is much higher. How much? Yeah, around 300 times. 300 times. That shows very, very, very highly skewed data distribution. Okay. So we can capture when we see a certain type of this data. Yeah, it takes time and it takes the experience. But however, when you see certain table, when you see certain graph, okay, you can almost immediately, or you can intuitively understand or capture what is the problem. What is the problem? Maybe I cannot teach that because that requires a lot of insights and the wisdom and the taxing knowledge. you must learn by yourself. But however, the purpose of the displaying and summarizing the data is we want to we want to transform the data into information, and then from information to knowledge, and knowledge to insight, and insight to wisdom. Okay? Good. Anything else? Okay, so that's a cumulative. And yeah, when we have a continuous, when we have a continuous quantitative data, the first thing we must do is we must set the class. Okay, whatever. Good, and there is a stem and leaf display. Okay, pivot table, we will learn that later. Okay, and cross tabulation we learned, and the Simpsons Paradox. Okay, when we have a contradictory conclusion, okay, we must double check the data quality. And by using the scatter diagram, we can say something. We can say something like this. Okay, yesterday the Owlin, Owlin? No. Yeah, okay. Somebody, some smart guy. Luke. Okay, yeah, Luke. So I give an example of what? Sleep. Yeah. And then I suggest this case, the sleep and the GPA. And that has one of our WKU students last semester, and she conducted a small research. And what is the relationship between the sleep hours and the GPA? And she found out this. Really, if you sleep more, okay, the GPA is higher. Huh? So yeah, that data tells. Data told that, and there is a positive correlation. There is a positive correlation between the sleep hour and the GPA. So if you want to get a GPA, the higher GPA, and then you must take more sleep. Can we say that? Can we say that? If we want to get a better GPA, and then you must take more sleep? Oh, but how about the data said? What is wrong? What is wrong? Can we say that? Okay. The problem is, it's not yet proven the causality. The causality, cause and effect. Okay, we don't know. We don't know what is the cause and effect of these two variables. For example, okay, what if I change this? It's a GPA and sleep. And the relationship must be same. The relationship must be same because we use the same data. Good. So then, can we say if you have a more GPA and you can take more sleep? It sounds crazy. It sounds strange. Okay? And this problem is causality issue. What causes this? What causes this? We don't know much about that. So this is a good start. This is a good start. Knowing what is the relationship between two variables is a nice start, but that's just a start. In order to prove the causality relationship, okay, A causes B, okay? In order to prove the causality, we must use a lot of theories, previous data, and the previous reasonings, and the logics, and more experiment. We need more effort. We need more effort to prove that causality. Absolutely. And many times, the researchers just report, okay, I found a very interesting relationship between two variables. Okay, when you take the vitamin D more, and the cancer is decreasing, and so we must take more vitamin C. Can we say that? No, not yet. We need a lot of effort to prove that. Okay. What is another good example? Yeah, still I have some difficulties. There was okay. Yeah, something like this. Okay, so when you consume more hamburger, yeah, when you take more hamburger, and the global warming is getting slower. Yeah, and but however, that was proven. The data told that. So when we take more hamburger, okay, when we eat the more meat and when we eat the more something, and the global warming is getting slower. And somebody proved that. Somebody found out that. But however, though, what is wrong with that data? There is no causality. There is no causality. Yeah, I eat the hamburger, so then, why that make the effect? Why the global warming is getting slower? Data tell, but however, we must think about that. Why? What causes and what is the effect of that? Okay, so the correlation, or this kind of simple correlation or the regression does not tell what causes what. Okay, so that's a limitation of the statistics. So even though you got this kind of the relationship result, please double check, think it again, and then please study more about what is the cause and effect, who drives something what. Okay, that's very important. Okay, and yeah, scatter diagram. Okay, and the extended bar chart. Okay, so cross tabulation, paradox. Okay, relationship, but don't believe that until you can prove that. Okay, and then we will see more about it. The extended bar chart, and bar chart has a lot of options. And then the side by side bar chart looks like this. Okay, so we have two variables, and we have the four categories in the cross table. And then we can display like this. Okay, by category, and we compare these two side by side. Okay, good. And so we call this is side by side bar chart. Side by side bar chart. And it displays that we can easily compare. We can easily compare what is more larger, like this. And the colonial style of the home, or colonial style of the house, there are a lot of the low-priced house. And while there is a very little, the high-priced house. And then logo style, that's the opposite. Okay, the high, expensive houses are outnumbered. Okay, like this. Yeah, we can compare. We can easily compare side by side. Okay, good. And the another bar chart is stacked bar chart. Stacked. Yeah. Instead of comparing this, we just move this to here. Okay. Then we can compare this. And this is good for capture the total number of this. Total. Okay, and we call this is stacked bar chart. We stack over another category, and we can stack more. It depends on the number of variables. And the classes. Okay, we call this is a stacked bar chart. Stacked bar chart. Okay, good. And this is my the favorite, one of my favorite graphs. And we can compare by proportion. And by using the relative frequency or the percent frequency, we can display this, okay? And everything must be 100%, 100%, okay, 100%, 100%, 100%, 100%. And then we just enforce that the making a whole thing, and then we can compare what is the proportion of a certain category, certain class. Then that gives us a more clear understanding. Clear understanding, okay? For example, A-frame usually less expensive, more cheaper. Okay? While the log style home, that contains more expensive homes by proportion. By proportion. Okay? And we call this is a stacked bar chart and the proportional stacked bar chart. Okay, stacked bar chart, number, stacked bar chart for proportion. Okay? Good. Good. So let's summarize. And then we see that we will use the Excel to display something. Let's summarize the the summarization, summary of the quantitative data, how we can display something. Okay, when we have a quantitative data, no, okay, not quantitative. When we have a data, we can categorize that there is a categorical data and the quantitative data, and we can display, and we can summarize the categorical data like this. And then, let's focus on the quantitative data. When we have a quantitative data, we can make a table. We can make a table, and the table can contain frequency distribution, relative frequency distribution, percent frequency distribution, and cumulative frequency distribution, cumulative relative frequency distribution, and cumulative percent frequency distribution, and we can make a cross tabulation. We can do the cross tabulation, and we can make a cross table. Okay, table, tabular table. Okay, and we can display the quantitative data summary by using graphs. Okay, and then we can use the dot plot, we can use the histogram, we can use the stem and leaf display, and we can use the scatter diagram when we have a quantitative data. Quantitative data, okay? However, let's review the categorical data. When we have a categorical data, we can count. We just simply count, okay? And we can make a table, okay? We can display the frequency, relative frequency, and the percent frequency distribution. And we also can display that by using the cross table. That's possible, okay? Table. And then when we have a categorical data, we can display the categorical data by using bar chart, pie chart, and side by side bar chart, and the stacked bar chart. That's possible. That's possible. Okay? And however, before we clearly distinguished it from each other. We clearly distinguished each other. But nowadays, we don't much care. We don't much care about that. We don't much care about that. If we can display, and if we can display that the data in a better way, we can use any kinds of data, any kinds of table, any kinds of the display. Okay, so I will give some example. Have you ever heard about the infographics? Infographics. Nowadays, we have infographics. Infographics. Have you ever heard about that? Infographics. Infographics is information plus graphics. Okay? And nowadays in the business, okay, we are using a lot of this kind of the infographics by using a lot of tables and a lot of the graphs. And let's see. Let's see an example. Hey. Wake up. Okay. Let's see. Where's the infographics? Yeah, can you type in the infographics in your laptop? Okay, maybe. Let's see. Infographics. Hello. Where? Hey. Yeah, technology problem. Hey. Hey. Why this is not working? Hey. Wake up. Wake up. Yeah. Infographics. Okay. It's working. Google. Yeah. Okay. Yep. Infographics. And let's see a few number of the samples in here. Hey, wake up. Dead long, okay. And here I want to have education something, infographics, guideline, process to food healthy. What else? Why infographics work? There must be an example of the business IT word triathlon. Yeah, now. What is the business infographics? First, what? Plastics. Central Europe. Hey, okay, so infographics for business. Business. Okay. Modern design business infographics. Something like this. Okay, this is pie chart. Okay, so yeah, something like this. Yeah, what? So this is a simple pie chart. This is pie chart, but however, it contains a lot of information in here, and that looks more better. Anything else? Process. Okay, and success. Yeah, some sort of market situation. Okay, maybe you can display like this. And what is more creative, something else? Okay. So you can see a lot of bar chart, pie chart, bar chart, pie chart, and yeah, the display of the proportion, and that's very similar to the stacked bar chart. Okay, and pie chart, and line graph. Okay. So, what is the purpose of the summarization and displaying the data by using the graphics? Okay, simply we have only one purpose. We have only one purpose in business. Why we summarize and why we display by using graphics. We have only one purpose. We have only one purpose. Why we use a lot of this kind of the infographics in business. Just one. We have only one purpose. If you understand this, okay, so you can use whatever you want. What is the purpose of using a lot of infographics in business? Why we use a lot of graph? Yeah, the purpose of the statistics is just to use, we want to explain and we want to predict something. Okay, good, whatever. So what is the purpose of this? Why we use a lot of graphs? For what? In business, in business. In business. Delivering information is one thing, but however, the predicting something else is important. But however, why? Why we use this kind of, a lot of the infographics? The purpose of using this kind of the summary and then the displaying the data by using the infographic is, I want to persuade. I want to persuade my boss. I want to persuade my customer. I want to persuade my client. I want to persuade my people to do something. To understand, to make an action, and to change something, and to make it better. Okay, persuade. So, yeah, we have only very simple law. If you can persuade somebody, you can use any kinds of things. Any kinds of infographics, any kinds of tables, any kinds of the bar chart, or pie chart, whatever. Okay, it's okay. Yeah. Before, we clearly distinguished that how we can display the categorical data or the quantitative data. But nowadays, no, I don't care. We don't care. We don't care. We can persuade something. If we can persuade somebody effectively, I must be able to use any kinds of things. That's all right. That's all right. Okay. And nowadays, many times we use a lot of graphics. But however, nowadays, do you know that we are using a lot of video? Video. Okay. And for example, maybe you see a lot of video in Kickstarter video. Oops. Kickstarter video. Yay. Images. No. There must be a video. Yeah. Okay, for example, just make it more short. I wish that worked. Okay.
Hi, I'm Yancey from Kickstarter. We know how intimidating it can be to make a project video. It feels weird to sit in front of a camera. It's awkward. You don't know how you're going to look. None of us are used to doing it. But the simple fact is, making a video on Kickstarter is not that difficult. There's no wrong way to do it. You just have to make one. So we're here at Kickstarter headquarters to give you some ideas about the best ways to make a project video. Now, you might think you need a film school friend who knows Final Cut Pro and has all sorts of fancy gear, but the fact is you can make a project video with just about anything.
And that's why I'm here on Kickstarter. Let's make this project happen together.
And always a personal touch is a great idea. Just talk to the camera and say what you want to do.
Welcome to my Kickstarter page. Help me make a new record. Hee-haw!
We've all seen the crazy elaborate videos that people post, and if you want to do one of those, go for it.
This is not working.
Cut.
For me.
I need more passion. From the top.
Over 80% of projects on Kickstarter launch with a video. Everybody's done one. It's not that hard. Just sit in front of a camera, press record, and let it go. No matter what you do, it couldn't possibly be more ridiculous than this.
That's true.
Hi, I'm Yancey from Kickstarter.
Okay, good. Okay, so I just want to say, we in the statistics, however, in business statistics, we don't much care about a table, graphs, or the video, or hologram, or the laser show, whatever. Okay, whatever. If we can persuade somebody, we must be able to use whatever. Okay, don't limit yourself. You must use the graph. You must use the table. Yeah, we have a tradition. We have a norm. But however, we must be more creative nowadays. Okay. The purpose of the business statistics is we want to persuade. Okay, we want to persuade. So feel free use any kinds of graphical display. Really, I'm serious. Don't limit yourself. Everything will be fine. More effective. Yeah, if you can persuade somebody more effectively and efficiently, use that. Use any kinds of things. Bobber, that's okay. And the data, that's okay. Mathematics, that's fine. Artificial intelligence, that's all right. Hologram, that's fine. Laser, that's good. Okay? And then performance, that's all right. Role playing, that's fine. Video, absolutely fine. Okay? That's just a start. That's just a start. Good. And yeah, let's see more. And okay. No. Save. So yeah, last week we tested. Yeah, we played with the Excel sheet. So do you remember? We played a little about this. Okay, and there is a shadow market data in here, 25, and then by using this, okay, so we summarize that, okay, the frequency, OTC, NYSE, by when we have a categorical data, okay, and that is how we can convert that information in that data to this kind of number, count. Okay, we use count if. Okay. So then, yeah, let's go a little bit more. So when we want to calculate the relative frequency, we can calculate simply that frequency divided by what? Total number. Okay, that's total number. Okay, good. And that is this divided by total number. Okay, and then that divided by total number and sum. If we sum everything, that must be 1. That's collectively exhaustive. Okay, and then there is equal this. No. Okay, so let's do that like this. Equal this. Okay, and equal this. And however, so yeah, I don't like to change the scale something. But however, in here, when you click that, and there is a format cell. There's a format cell, and then here, when you click the format cell, you can set a certain number of options. Okay, general number, currency, accounting, data, something. And I want to set this data as %. And the decimal? No decimal. Okay. Yeah. Okay. Just one more. Okay. 1 decimal. And you can display the % data like this. Okay. You don't need to multiply the 100. And personally, I don't like that. Okay. So like that. So then, when we put that information, that data, and convert the data into the number, and then we can calculate the relative frequency and the % frequency. Then we make a graph like this. Bar chart. Okay. There is. Okay. 5, 17, 3. 5, 17, 3. 5, 17, 3. Like this. Okay, and AMX, OTC, NYSE. So we can easily create this bar chart when we have a table. Good. And yeah, let's try to make a of the stock market. We don't have that. Okay, so let's make a pie chart. Okay, pie chart. And yeah, I want to show this, the percent frequency. Okay, so we'll do this. And and then in here, there is an insert. Oops. There is a home, there is insert, and there must be recommended pie chart. Okay. You can see the bar chart, and the stacked bar chart, and advanced bar chart, and the line graph, and that's something. And there is a combination of the line graph and the bar chart, and the scatter diagram in here. And however, I want to make a pie chart. And like this. Oops. And I want to add a data label. Yeah, like this. Okay, 20%, and 68%, and 12%. Yeah, that's easy. That's easy. Okay, and however, when we want to make it more like this, okay, so I want to see this, and click the control, and this, okay, please, choose this first, and then choose this again. But when we we use your left finger and push the control. Okay, so let's see. Okay, click this first. Okay, and use your left finger and push down the control, and then click this again. So you can set the 2 columns. Okay, good, and go to insert and pie chart. Okay. Like this, or you can choose more. Okay, whatever. Let's make a more simple one. Okay, good. And click the graph, click the pie chart, and the right click, and you can add the data label. Then you can show the data percent in here. Okay, and under here there must be the automatic labels. Okay, and you can say that, okay, stock price, percent, stock, so percent of stock exchange, market, so like this. Okay, so we can easily make a pie chart. So like this, when you have a table, we can easily convert that table information into the graphical display. And then Excel can help you. Okay? And we just learned about it, how to summarize a table, and we converted that table into the graphical display. This chapter, okay, in this chapter. But however, we will use that. We will use this kind of technique in the chapter 3, 4, and 5, more practical way. Okay? Good. And we covered the chapter 2. And do you have any questions about chapter 2? Descriptive statistics, how to displaying, summarizing data, and displaying the data. Do you have any question? Chapter 2? No? Okay, good. And we covered the chapter 2. That means homework. Okay? And next week is a break. Okay, national break. But that's not for my national break. I must stay in here. Whatever. Okay, so please let me have your homework next Monday. Okay? Good. And that's it, and I will see you after next week. Good. Thank you. Bye. And that's